Hello everyone. In this video, we will explain equation of plane containing line of intersection of two planes and how to determine a unique plane by giving additional conditions such as passing through a point, parallel to a line, or perpendicular to a plane, or parallel to a plane, etc. This model particularly is very important in both JEE Main as well as JEE Advanced. Here is our concept. Equation of plane passing through or they can give containing the line of intersection of the planes pi1 a1x plus b1y plus c1z plus d1 equal to 0 and pi2 a2x plus b2y plus c2z plus d2 equal to 0 is pi1 plus lambda into pi2 equal to 0, where lambda is any parameter, or we can write lambda 1 into pi1 plus lambda 2 into pi2 equal to 0, where lambda 1 comma lambda 2 belongs to R, and of course lambda 1 and lambda 2 both should not be 0 at a time. So that's where sum of squares is not equal to 0. So now here, how do we prove that this one? You see, here I have drawn some planes and I will give the names. This plane is pi1, assume this is the plane pi1. And this plane is pi2, red one. Red one is plane pi2. Now these two planes meet along a line. Meet along a line. You can think that 2 pages in a book. 2 pages in a book, they meet along a line. So this is the line of intersection of two planes. L is the line of intersection of two planes. Here I am writing L, the line of intersection of pi1 and pi2. Pi1 and pi2. So now they are asking what is the equation of plane containing this cell. So here I have taken another plane equation in green one, which contains the line L. So this plane is pi1 plus lambda pi2 equal to 0. There exist infinite number of planes containing line of intersection of two planes. Line of intersection of two planes. You can think in your room, you take two walls. So two walls meet along a line. Now we need another wall containing that line. So here we have to prove that how that plane containing line of intersection of pi1 and pi2, pi1 plus lambda pi2 equals 0. You consider a point on this line L, right? So let you take some p x1, y1, z1 belongs to L. This implies p lies on pi1 and pi2 because L is the common line of intersection of pi1 and pi2. Remember, two planes are always meet along a line, means they have infinite solutions, or they are coincident infinite solutions, or they are parallel. So for two planes there are only three possible cases. they meet along a line, they are coincident, means one plane lies on the another plane, or two planes may be parallel. When they are parallel, no solution exists. So this particular concept is important in matrices, solving of system of equations. So here you consider some point P null, means this is an arbitrary point. So P lies on pi 1 as well as pi 2. So therefore P lies on pi 1. So substitute the point P in pi 1. We will get A1 x1 plus B1 y1 plus C1 z1 plus D equal to 0, D1. And substitute the same point P in pi 2. You will get A2 x1 plus B2 y1 plus C2 z1 plus D2 equal to 0. Since the point lies on both the planes. So now adding these two, multiply the second relation by some lambda and adding to the first equation. This implies A1x x1 plus B1 y1 plus C1 z1 plus D1, multiplying second equation by some lambda into A2 x1 plus B2 y1 plus C2 z1 plus D2 equal to 0. So irrespective of the value of lambda, it is always true. Because the first expression is 0, second expression is also 0. So what is the meaning of this? This implies A1x plus B1y plus C1z plus D1 plus lambda into A2x plus B2y plus C2z plus D2. So instead of x1, y1, z1, I wrote xyz. Contains. This equation satisfies px1, y1. px1, y1. So therefore, pi 1 plus lambda into pi 2 passes through an arbitrary point, P belongs to pi 1 and pi 2. So this is the equation of plane containing line of intersection of two planes. Whenever you find this sentence, equation of plane passing through line of intersection of two planes, or equation of plane containing line of intersection of two planes. It is very, very important with respect to JEE Main as well as JEE Advanced. So in order to find the value of lambda, here you see, to measure lambda, we need some additional geometrical conditions. Means how do we find the lambda? So for that, we need some additional geometrical conditions. What are these additional geometrical conditions? You see, to find the value of lambda, they may give additional geometrical condition like passing through a point, which means that you need to substitute this point in pi 1 plus lambda pi 2 equals 0. Then you can find the value of lambda and substituting back to the equation. Second condition, you see here, parallel to a third plane, pi 3. Parallel to a third plane is same as a perpendicular to a line 1. I'll give you several examples picked from JEE Main. Third one, perpendicular to third plane, like this, perpendicular to third plane, like this. Two planes are perpendicular. It is same as parallel to a line. It is same as parallel to a line like this. Both are same. Or at a distance of p units from a point Q. Means that particular plane must be at some distance from the given point. So I will solve now a few questions from previous J main exactly based on this concept. So here are a few questions from previous J main. Here you see, asked in February 1st, 2023, let the plane P passes through the intersection of the planes. Assume this is pi 1 and this is pi 2. So here I am writing this is pi 1 plane and this is pi 2 plane. They are meeting along a line L. This is the line L. And see, let P passes through the intersection of these two planes. So this is the plane P. That black one, this is the plane P. Okay. And perpendicular to 2x plus y minus z plus 1 equal to 0. So assume this is plane 3. So this P must be perpendicular to plane 3. Perpendicular. So here pi 3 and P are perpendicular. So now we want to find D is the distance of P from this point. Then what is D square? So now what is the plane? Plane P is, it contains line of intersection of pi 1 and pi 2 equal to 0. So this implies first equation is 2x plus 3y minus z minus 2 plus lambda into second plane x plus 2y plus 3z minus 6 equal to 0. If you want, you can write directly like this. X into x coefficient in the first plane is 2. For second plane, multiply by 2. So lambda into 1 lambda. Similarly, plus y into 3 plus 2 lambda plus z into 3 lambda minus 1 minus 2 minus 6 lambda equal to 0. So this is the plane P. Now how is this plane P? It is perpendicular to pi 3. So this is perpendicular to pi 3. So two planes perpendicular means their normals also perpendicular. So this is perpendicular to pi 3. Therefore, the product of DRS of normal to the planes equal to 0. So what are the DRS of normal to the plane pi? 2 plus lambda, 3 plus 2 lambda, 3 lambda minus 1. So these are the DRS of plane P. And what are the DRS of plane 3? 2, 1 minus 1. So here it is perpendicular to pi 3. So therefore I'll write 2 plus lambda into 2 plus 3 plus lambda, 3 plus 2 lambda into y coefficient here 1, 3 lambda minus 1 into here z coefficient is minus 1 equal to 0. So we need to find out the value of lambda. Here you see this is 2 lambda plus 2 lambda, 4 lambda minus 3 lambda. So you will get only 1 lambda. Here 2 into 2, 4 plus 3 into 1, 3. It is totally 7 and 7 plus 1, 8. So we got lambda equal to minus 8. Substitute lambda equal to -8 in P. Substitute in P. You will get the plane P. So what is the plane P? The plane P is now plane P is substitute lambda equal to -8 in plane P. Here you substitute. You will get -6x. This is the plane. 3 minus 16 minus 15y minus 13y minus 13y. And this is minus 24 minus 25z. This is plus 48 minus 2. So plus 46 equal to 0. Or you can write 6x plus 13y plus 25z minus 46 equal to 0. Now what else we need to find out? That D is the distance of P from the point -7, 1, 1. So this is equal to the perpendicular distance from a point to the plane. Substitute this -7, 1, 1 in the plane pi. You will get that 42 minus, this is minus 42 plus 13 plus 25 minus 46 whole by root over. This is 6 square 36 plus 169 plus 25 whole square is 625 and this whole square. Numerator reduces to 50 square whole by denominator reduces to 830. So 50 square is 2500. 1 0 will be cancelled. So the answer is 250 by 83. So every question, almost all majority of questions like this only. Either plane containing the line of intersection of two planes parallel to a plane, perpendicular to a plane, or passing through a point, or it is at some distance from a point. Now let us see the next question. Let the plane containing the line of intersection of the planes P1 and P2 instead of pi1 and pi2. They have given P1 and P2. Passes through 2 points. Now you can ask the question, sir, why they have given 2 points? 1 point is enough. But here in one plane, they have given another variable, another constant, that is lambda. So you need to find out 2 constants. Here they have used the lambda, so we will use another constant. So what is the equation of plane containing P1 and P2? Equation of plane containing line of intersection of P1 and P2. Line of intersection of plane 1 and plane 2 is P1 plus some mu into P2 equal to 0. So which means that this implies you just need to write the given planes directly. X plus lambda plus 4 into y plus z minus 1 plus mu into the second plane is 2x plus y plus z minus 2 equal to 0. Now it passes through 2 points. It passes through 2 points. 0, 1, 0 and 1, 0, 1. In fact, it is not necessary to write because they have given. So substitute the first point. So therefore, substituting the first point 0, 1, 0, x is 0, here y is 1, so you will get lambda plus 4 and z is 0, so minus 1 is here, plus mu into substitute x 0, it becomes 0, this is 1 and this is 0 and minus 2. 1 minus 2 is minus 1. So mu into minus 1 equal to 0. So we got one equation in terms of lambda and mu, that is lambda minus mu plus 3 equal to 0. Right? Now substitute the second point. Substitute second point. 1, 0, 1. So substitute x plus 1 here. So 1. And anyway, y value is 0. Z value is 1. So 1 plus 1 minus 1 plus mu into. Here also substitute x1, y0, z1. So you will get 2 plus 1 minus 2 equal to 0. This implies here you will get mu plus 1 equal to 0. So this implies mu equal to minus 1. This value put in equation 1. You will get lambda value. Therefore, lambda equal to minus 4 we got. Now they are asking the distance of the point 2 lambda, lambda minus lambda from plane pi 2. From plane pi 2. So here the perpendicular distance from the point here given 2 lambda, lambda minus lambda equal to. This is the point. So substitute lambda equal to minus 4. You will get minus 8 minus 4 plus 4 from plane 2. Plane 2 means this is the plane. So what is the perpendicular distance? Modulus of, substitute this point in this plane. 2 into minus 8 plus minus 4 y coordinate and the z coordinate is 4 minus 2 whole divided by root over x coefficient is 2. So 2 square plus 1 square plus 1 square. So this you will get here, you see this is minus 16 minus 20 and anyway 4 cancelled. So minus 18 modulus is there. 18 by it is root 6. So this is equal to, you will get 3 root 6. So this is simple question asked in January 2023. Before question also asked in January 2023. So here is another question asked in JEE Main 2021. Equation of let the equation of plane that passes through the point 1, 4, minus 3. Assume this point is P. Okay. And contains the line of intersection of the planes. Assume this is pi 1 and this plane is pi 2. B, this is the required plane. Assume pi 3. So plane containing line of intersection of given planes is, directly I am writing that pi 1 plus lambda pi 2 equal to 0 implies. So pi 1, in pi 1 what is x coefficient? 3. Multiply lambda to the second plane. So what is the x coefficient when after multiplying by lambda you will get lambda. So x into 3 plus lambda plus y into, in first plane y coefficient is minus 2 In second plane, y coefficient is 5, multiply with lambda. So 5 lambda plus z into, in first plane, z coefficient is 4. In second plane, it is minus 2, multiply with lambda, minus 2 lambda. In first plane, constant is minus 7. Second plane, constant is 9, multiply with lambda. In this way, you may solve the question little faster. Right. So now it passes through 1, 4, minus 3. It passes through 1, 4, minus 3. So this plane passes through this point, P. So therefore, substituting this point in the above plane, x coordinate is 1. So 1 into 3 plus lambda plus 4 into minus 2 plus 5 lambda minus 3 into 4 minus 2 lambda minus 7 plus 9 lambda equal to 0. Now only simplification part is left. So how many lambdas are there? Calculate. Lambda, 5 lambda, totally 6 lambda, and minus of minus 3 into minus 2, this is again 6 lambda. So totally 13 lambda plus 9 lambda. So we have 22 lambda. Now what is the constant? Here minus 12, minus 7, so minus 19. Here minus 8, minus 27, plus 3, minus 27 plus 3. So minus 27 plus 3 minus 24 equal to 0. So here little calculation mistakes I have done. Again I will do this. This implies. So I'll just write entire thing. 3 plus lambda minus 8 plus 20 lambda minus 12 plus 6 lambda minus 7 plus 9 lambda equal to 0. Well, so here totally how many lambdas we have? 9. 9 plus 6, 15. 15 plus 20, 35 plus 1, 36 lambda. Now what is the constant? This is minus 20, minus 27, minus 27 plus 3. So minus 24 equal to 0. So this implies you will get lambda equal to 24 by 36. It is 12 2s, 12 3. So substituting in 1, you will get the plane. Put in 1. Therefore, we get lambda equal to 2 by 3. Here 3 plus 2 by 3 is 11 by 3. So 11x by 3. Substitute here minus 2 plus 10 by 3 plus 4 by 3. And substitute here 4 minus 4 by 3, 8 by 3, 8z by 3. And here minus 7 plus this is minus 7 plus this is 3 3's lambda minus 7 plus lambda. So it is plus minus 1 equal to 0. So this implies multiplying with 3 because observe here they have given 3. That's why I am multiplying. So multiply with negative sign also because here they have given plus 3. They have given plus 3. Observe. So multiply with negative minus 11x minus 4y minus 8z plus 3 equal to 0. So therefore, alpha plus beta plus gamma equal to, it is a very simple question, you will get minus 23. So be careful, they have given here plus 3. That's why we need to multiply with the negative sign. So here is another question asked in January 2023. It is also a very good question. Let the equation of plane passing through the line of intersection of two planes. So this is pi 1 and pi 2 and parallel to a line given in unsymmetric form. Parallel to a line given in unsymmetric form, BAX plus BY plus CZ equal to 65. Then the distance of the point ABC from the plane. So they have mixed several basic concepts in order to increase time bound. In order to increase the time bound, means to solve such kind of questions, we need a little 1 or 2 more minutes to solve the question. So here, assume this is the plane 1 and this is the plane 2. So this is the plane containing line of intersection of given planes. So pi 1 plus lambda pi 2 equal to 0. Right? And this is the line given in unsymmetric form. This is the line given in unsymmetric form. So first what we will do, equation of plane containing the given line. The given line is this, assume this is L1. Okay. So given line is pi 1 plus lambda pi 2 equal to 0. So pi 1 plus lambda pi 2 equal to 0. Now we need to substitute pi 1 and pi 2. Substitute. Here you see. X coefficient in the first plane is 1. In second plane, x coefficient is 1 and multiply with lambda. So you will get x into 1 plus lambda. Next, plus y into minus 2, y coefficient in the first plane. Second plane, y coefficient is 1 into lambda. Just in order to save our little time. In first plane, z coefficient is minus 1. Second plane, z coefficient is 3. Observe. So 3 lambda minus 5 lambda equal to 0. So this is the plane. Assume this plane is some pi 4 or it is equation 1. Now what is L1 here? L1 is x plus y plus 2z minus 7 equal to 0 equal to 2x plus 3y plus z minus 2. So line in unsymmetric form. So what are the DRS of L1? For this plane, normal is n1 bar equal to I plus j plus 2k. And for this plane, the normal is 2i plus 3j plus k. Now we need to find out what are the DRS of this line L1. So the DRS of line L1 is now parallel to N1 bar cross N2 bar because L1 lies on both the planes. So L1 is perpendicular to N1 and L1 is perpendicular to L2. So therefore N1 bar cross N2 bar equal to determinant of I, J, K. First normal is 1, 2, 1, 1, 2. Second normal is 2, 3, 1. So this is equal to I into 1 minus 6, so minus 5i, 1 minus 4 minus 3 plus 3j, because minus 0. And this is 3 minus 2, 1 plus k. So these are the DRS of line L1. So therefore, DRS of L1 or minus 5, 3, 1. Now you see the plane pi 1 plus pi 2 is parallel to L1. So which means that this line is perpendicular to the plane, which means this is normal. So normal of required plane is perpendicular to L1. So normal of required plane is perpendicular to this one. So now here 1 is perpendicular to L1, implies product of DRS is 0. So minus 5 into, what are the DRS of plane 1? What are the DRS of normal to the plane 1? 1 plus lambda, lambda minus 2, 3 lambda minus 1. So minus 5 into 1 plus lambda plus 3 into lambda minus 2 plus 1 into 3 lambda minus 1 equal to 0. So by simplification, you will get the lambda value of lambda. This implies minus 5 lambda plus 3 lambda, which means that only lambda. This is minus 5 lambda plus 3 lambda minus 2 lambda plus 3 lambda. It is lambda. It is minus 5, minus 6, minus 12, minus 1, totally minus 12. So this is equal to, this implies lambda equal to 12 we got. Now we need to substitute in the plane, right? So what is that plane? So this is the plane equation 1. Plane equation 1. We just substitute that value. Therefore, put in 1. Put in 1. We get 13x plus 10y and 36 minus 1 plus 35z minus 65. That's equal to 65. We got this. Now, I'm going to see the question again. See, the required plane is ax plus by plus cz plus 65 equal to 0. So, ABC values are now, so therefore, this is A value and this is B and this is C. So now the perpendicular distance from ABC, that is the point 13, 10, 35 to the plane is modulus of, substitute here 26 plus 20 minus 35 plus 16 whole by under root 9. So this is equal to, you will get, this is 46, 72 minus 35, that is 27 by 3 equal to 9. Now let us see the next question. So this question asked in 25th June 2022 regarding, they have given the planes in vector form. So this is the plane 1 and this is the plane 2. So what is the plane 1 now? So plane 1 is in Cartesian form, r bar equal to xi plus yj plus zk. Substitute here, you will get x plus 3y minus z minus 5 equal to 0. What is plane 2? Plane 2 is 2x. Here you see, here, this one. R bar is xi plus yj plus zk. So here 2x minus y plus z, only dot product of vectors, minus 3 equal to 0. Now, what is the plane containing or passing through intersection of these two? So, equation of plane is now pi 1 plus lambda pi 2 equal to 0. This implies you can write x plus 3y minus z minus 5 plus lambda into 2x minus y plus z minus 3 equal to 0. Now it passes through 2, 1 minus 2. It passes through 2, 1 minus 2. So therefore, substitute this point directly. Substituting here 2 plus 3 minus of minus plus 2 minus 5 plus lambda into 4 minus 1 minus 2 minus 3 equal to 0. So you just simplify it. The first, this is sum 7. 7 minus 5 is plus 2. And this one is minus 6 plus 4. So minus 2 lambda equal to 0 implies lambda equal to 1. So we got equation of plane. Now the plane pi is, substitute lambda equal to 1 here. You will get x plus 2x, 3x. And this is 3y minus y plus 2y minus z, and this is plus z, minus z plus z becomes 0, minus 5 minus 3 minus 8. So this is the plane. Now question is not yet finished. They are asking, let the position vectors of x and y, let the position vectors of x and y given as 2 points. They are asking that the positions of these points with respect to this plane. The positions of these points with respect to the plane. So when you substitute these points in the plane, if we get both values positive or both values negative, then they lie on the same side of the plane. When you are substituting 2 points in a plane, if you get opposite sign, then those points lie opposite side of the plane. So first, so here what is the x point? That x point equal to 1 minus 2, 4. And what is y point? Y point is 5 minus 1, 2. We need to substitute these 2 points in the plane. But they are asking, you see, first option is x, x plus y. So what is p of x? Substitute x point in this. So 1 minus 4 minus 8. You just need to check whether it is positive or negative. Negative. Now what is x plus y? Point x plus y. So x plus y vector is, you will get that 6 minus 3 and 6. They are asking x minus y and y minus x also. So what is x minus y? X minus y equal to minus 4, minus 1 and 2. Okay. So what is p of x plus y? P of x plus y equal to, you substitute these coordinates in this plane. It is 18 and minus 6 minus 8. So this is positive. This is positive. So here at x, when you are substituting x point, it becomes negative expression value. When you are substituting x plus y point, it is positive. So they lie on both sides. So this implies x comma x plus y lie opposite side of plane P. Let us check. Now what is x and y? So what is py? Let us check py immediately. Substitute these coordinates. You will get 15 minus 2 and minus 8. So you got positive value. So which means that x comma y are on the opposite side, opposite of plane pi. So the option C is matching, fortunately. But you need to check the remaining options also. So here is another model based on equation of plane containing line of intersection of two planes. Here you see, let the plane, assume this is pi 1. This is pi 1. Be rotated through a right angle about its line of intersection of another plane, pi 2. So here you see, pi 1 is rotated. Remember, read the question carefully. Which plane is rotated? Pi 1 is rotated through an angle, right angle, about its line of intersection. So this is pi 1 and this is pi 2. So about this line L, this pi 1 is rotated through an angle 90 degrees. 90 degrees. Assume this is plane 3. So now what is the equation of plane 3? Plane 3 is pi 1 plus lambda pi 2 equal to 0. Pi 1 is rotated through an angle 90 degrees about line of intersection of pi 1 and pi 2. Like you can say, you take 2 pages in a book and you rotate one page which is perpendicular to that plane. So this implies substituting pi 1 and pi 2 here. See x into x coefficient in first plane is 2. In second plane 1, multiply with lambda plus y into 3 minus 3 lambda plus z into 1 plus 5 lambda plus 20 minus 8 lambda equal to 0. So this is plane 3. Now what is the angle between plane 1 and plane 2? So here, angle between pi 1 and pi 3 equal to 90 degrees. So which means that plane 1 is perpendicular to plane 3. When two planes are perpendicular, their normals are also perpendicular. So N1 perpendicular to N3. So for this is the normal N3. For this is the normal N1. So this implies N1 bar dot N3 bar equal to 0. So now it becomes very simple that you see that plane 3 is perpendicular to plane 1. So product of DRS of normals of pi 1 and pi 3 is 0. So this is pi 1. 2 into 2 plus lambda plus 3 into 3 minus 3 lambda plus 1 into 1 plus 5 lambda equal to 0. Now what is the value of lambda? This is minus 9 lambda and 5 lambda plus 5 lambda plus 2 lambda. So minus 2 lambda. Now what is the constant? This is 9. 9 plus 4, 13. 13 plus 1, 14. Implies lambda equal to 7. So we got lambda equal to 7. So equation of plane 3 we got now. Equation of plane 3. Therefore, plane 3 substitute lambda equal to 7. Here you will get 9x. 3 minus 21 minus 18y. This is 35 plus 36 plus 1, 36z. And this is 20 minus 56 minus 36. You can cancel with 9. X minus 2y plus 4z minus 4 equal to 0. So this is plane 3. Now question is not yet finished. If the mirror image of 2 minus 1, 2 in the rotated plane, is B, A comma, B comma, C, then they are asking what is the ratio of A, B, C. So now the last part of this question is, if the mirror image of this point in the rotated plane is B, A, B, C. So now we'll apply that mirror image formula. You will have that A minus 2 by here x coefficient in the plane pi 3 is 1. B plus 1 by 2 by minus 2 equal to C minus 2 by Z coefficient is 4. We are applying the mirror image formula minus 2 times of, substitute the point in the given plane, 2 minus of minus here plus 1 plus 8 minus 4 by A square plus B square plus C square, 1 plus 4 plus 16. So this is equal to, the numerator is, it is 7. So minus 14 by it is 21. So we will get minus 2 by 3. So now equating the first, last, second, you will get ABC values. This implies A equal to, sending one that side, minus 2 by 3 plus 2. So you will get 4 by 3. Now B equal to 4 by 3 minus 1 by 2. 4 by 3 minus 1 by 2 equal to, this is 8 minus 3, 5 by 6. And C minus 2, C equal to minus 8 by 3 plus 2. That's equal to minus 2 by 3. So therefore, what is A is to B is to C? A is to B is to C equal to 4 by 3 is to 5 by 6 is to minus 2 by 3. Multiply with 6. Multiply with 6. You will get 8, 5, minus 4. There is another question asked in June 2022. If this plane is rotated about its line of intersection with this plane at an angle of pi by 2, which means that exactly same as of before question. After rotation, the plane passes through which point? So you please proceed as it is of before question and solve it. Verify the point in the rotated plane. Moving to next question, here you see the plane passing through the line and perpendicular to the plane is this. So here, this is the line L, pi 1 equal to 0 equal to pi 2. And perpendicular to this plane is given as like this. So here we need to find out the DRS of line L. So what are the DRS of line L? See here, L is parallel to N1 bar, comma N2 bar, where N1 bar equal to normal to the first vector, that is Li minus J plus 3 times of 1 minus L into K. And N2 bar equal to, it is I plus 2J minus K. So now I am finding the direction ratios of line. Line here is line of intersection of two planes. So L is perpendicular to both N1 bar and N2 bar, because line lies on pi 1 as well as pi 2. So this implies L is parallel to N1 bar cross N2 bar. So therefore, what is N1 bar cross N2 bar? I am finding direction ratios of given line. Determinant of I, J, K, L minus 1, 3 minus 3L, 1, 2 minus 1. This is equal to I into, this is 1 minus 6 plus 6L. So 6L minus 5 minus J into, it is minus L minus 3 plus 3L. So which means that 2L minus 3 plus K into, this is 2L plus 1. 2L plus 1. So now you see, this is the line L perpendicular to the plane. So here I am drawing a plane. This is the plane. Line is perpendicular to this plane. This line is perpendicular. Means the plane passing through this L. Plane passing through this L is perpendicular to this plane. So assume that so to explain very clearly, here I am drawing, I have drawn a diagram. This assume this is some plane 1. This is plane 1 and this is plane 2 and this is line of intersection of these two planes, and this plane contains this L and this plane is perpendicular to this plane. I have written here. So now L lies on this plane. So the normal of this plane, this is the normal, is perpendicular to L. Now N bar is perpendicular to L. This implies N bar is perpendicular to N1 cross N2 bar. where what is n bar? N bar is normal to the plane 3x minus 8y plus 7z. So 3i minus 8j plus 7k. Now apply the dot product, that 3 into 6l minus 5 minus of minus plus 8 into 2l minus 3 plus 7 into 2l plus 1 equal to 0. This implies only to confuse the student, they have given so much data and nothing is there. Okay, so just we need to find out DRS of line L. This implies 18L plus 16L plus 14L. It is 48L minus 15 minus 24. Okay, minus 39 plus 7. So minus 32 equal to 0. This implies you will get L equal to 16 2s and 16 3. So we got the value of L. Now, if theta is the angle between the line L and y-axis. So what are the DRS of L? DRS of L or the DRS of L are, these are the DRS of L. L equal to 2 by 3. So you substitute here 6L minus 5. Substitute L equal to 2 by 3. You will get 4 minus 5. That is minus 1, comma. Here this is 4 by 3 minus 3. 4 by 3 minus 3. It is minus 5 by 3. But before here minus is there. So 5 by 3. And substitute L equal to 2 by 3. 4 by 3 plus 1. It is 7 by 3. DRS of y-axis. DRS of y-axis are 0, 1, 0. Simply you can think as a vectors. They are vectors, not to think as vectors. They are vectors. So now, angle between these two, cos theta equal to. So cos theta equal to angle between these two vectors, modulus of this is 0 and only the middle term is 5 by 3 by under root 1 plus it is 25 by 9 plus 49 by 9 into anyway square root of 0 square plus 1 square plus 0 is 1. So this is equal to 5 by 3. After simplification, you will get 3 by under root 9 plus 74. 3 cancel. This is equal to 5 by under root 83. Now they are asking what is 415 cos square theta. So 83 into cos square theta equal to 25. Now we need to multiply another 5. Then you will get 415. So multiply with 5. You will get 415 cos square theta equal to 125. It is very good question. Indirectly, they are asking the angle between two vectors. So here is another question. Let P be the plane passing to this point and the line of intersection of these two vectors, these two planes. So therefore, what is the equation of plane type? See, the first one is x plus y plus 4z minus 16. Substitute r bar equal to xi plus yz plus zk plus lambda into the second plane is minus x plus y plus z minus 6 equal to 0. So it passes through. Substitute 1, 2, 3. You will get value of lambda and after that verify these points in the plane. That's it. Same model. And another question is, see here, PB the plane contains the line of intersection of these two planes. So I'll write here equation of plane. What is the equation of plane? X plus 2y, x plus y plus z minus 6 plus lambda into 2x plus 3y plus z plus 5 equal to 0. Now it is perpendicular to xy plane. It is perpendicular to xy plane. It is perpendicular to xy plane means parallel to z axis. So P is perpendicular to xy plane, which means that plane is parallel to z axis. Plane is parallel to z axis. So plane is parallel to z axis means normal of plane P perpendicular to z axis. That's it, over. So now only simplification part is left. This implies, so z axis DRS 0, 0, 1. So 0 into, what are the plane normal DRS? 1 plus 2 lambda plus 0 into 1 plus 3 lambda plus 1 into 1 plus lambda equal to 0. Remember, DRS of x-axis, 1, 0, 0. DRS of y-axis, 0, 1, 0. DRS of z-axis, 0, 0, 1. So therefore, we got lambda equal to minus 1. So we will get the plane equation as, substitute lambda equal to minus 1 here. We will get minus x minus 2y and minus 11. So this implies x plus 2y plus 11 equal to 0. Then the distance of this point 0, 0, 256 from this plane, right? So distance from that point equal to, here z coordinate is 256, but in the plane there is no z. So directly you can write modulus of 11 by under root 5. That's it, over. Here is another question. A plane P passing through line of intersection of two planes is this for some A and B. Then what is the distance of 3, 2, minus 1 from the plane? Okay, I'll write the plane equation P here. So here x plus 4y minus z plus 7 plus lambda into 3x plus y plus 5z minus 8 equal to 0. So just simplify this. X into 1 plus 3 lambda plus y into 4 plus lambda plus z into 5 lambda minus 1 plus 7 minus 8 lambda. Now this plane is same as of this one. So, and this plane 1. What is actual plane? Ax plus by plus 6z minus 15 equal to 0. Now 1 and 2 represent same. 1 and 2 represent same. 1 and 2 represent same. Represent same means they must be identical, represent same. So when they are identical, the ratios of x, y, z and constant all equal. So you can write that 4 plus lambda 1 plus 3 lambda by a equal to 4 plus lambda by b equal to 5 lambda minus 1 by 6 equal to 7 minus 8 lambda by minus 15. It is a different question. So now equating these two, automatically you will get value of lambda. So this implies just this is 3 2s and 3 5s. So do the cross multiplication. 25 lambda minus 5 equal to 14 minus 16 lambda. So this implies you will get 41 lambda equal to 90. Let me check once. So here it is the minus 5. So I forget this minus sign here. Minus and it is plus. So now you will get 9 lambda bringing this side. 11 lambda. 11 or 9? 9 lambda. So this is 9 lambda equal to minus 9. So this implies lambda equal to minus 1. So substitute here. Lambda equal to, we got minus 1. Put in 1. Put in 1. We will get equation of plane. So therefore, what is the equation of plane P now? 4x, put in 1, plus 5y, plus 4z. Okay, lambda equal to minus 1. So this is minus 2x and this is 3y. I thought it is 1. It's a minus 1. Minus 6y, minus 6z. Okay, and this is plus 15 over. So we got the plane. Now you need to find out the perpendicular distance from 3 to minus 1 to the plane 5. That's you can do. Here is another question. The plane through the line of intersection of this and parallel to y-axis. You just proceed that pi 1 plus lambda pi 2 is parallel to y-axis. So product of DRS equal to 0, which means that normal of this plane is perpendicular to y-axis. You just proceed.